Look at this massive expression, 2022 to the power of 2026. Calculating this by hand would take forever. All we want is the remainder after dividing by 2025. I bet your brain is already suggesting Euler's theorem. But hold on, don't make that mistake just yet. This problem is designed to mislead anyone who just memorizes formulas but skips the conditions. Euler's theorem is elegant, sure, but it comes with one strict condition that people often ignore. The theorem only works if these two numbers are coprime. That means they cannot share any common factors. So let's actually look at our numbers. Are they really coprime? 2022, sum of the digits is 6. Boom, multiple of 3. Now 2025, 2 plus 2 plus 5 is 9, also a multiple of 3. See the problem? They both share a factor of 3. The theorem does not apply. The formula is invalid here. Since the standard shortcut doesn't apply, we need a different approach. Look at this, 2025. It is a large composite number standing right in our way. But if we look closer, it is actually 81 times 25 in disguise. Since they do not share any factors, we can split the problem into two separate moduli. This is the Chinese Remainder Theorem. It is a powerful decomposition method. Let us tackle modulo 81 first. We need the remainder when this large power is divided by 81. Do not panic. 2022 is just 3 times 674. We are looking at a product of many 3's. And our divisor, 81, is just 3 to the power of 4. We have over 2,000 3's here, but we only need 4 of them to make an 81. That makes the whole thing a multiple of 81. The remainder? 0. Simple. 1 down, 1 to go. World 1 is in the bag. Now, welcome to the golden realm, modulo 25. It's flashy, it's messy, and it's waiting to be solved. This exponent is large, 2022 to the power of 2026. We are about to reduce it significantly. My golden rule, if a number is too big to handle, we reduce it modulo 25. Don't let the size intimidate you. Look at 2022, it is close to 2025. It is just 3 less than 2025, so it is congruent to -3. Swap it in, and since that exponent is even, that negative sign cancels out. It is gone. Time for a theorem. Do 3 and 25 share any prime factors? No common factors? Great, that's our green light. Coprime, which means we can use Euler's theorem to reduce that massive exponent down to size. For modulo 25, the cycle length is 20. That is when the powers start repeating themselves. This means we aren't computing a huge power. We're just cycling through a 20-step loop. So, how many full laps are hidden in 2026? We only care about the leftovers, the remainder. The large exponent just simplifies. Now we only care about 3 to the 6. Way easier, right? 3 to the 6th is 729. Now that is a number I can actually work with. Home stretch. In this world, 725 is congruent to 0. Ignore it. What's left? Just a beautiful, simple 4. We've got our two separate truths. Now comes the satisfying part, combining them. Since x is a multiple of 81, it is basically just 81 times some random multiplier k. Now we take that 81k and substitute it into our second rule. It has to act like a 4 in modulo 25. 81 is a bit bulky, but 75 is a clean multiple of 25, so let's just reduce modulo 25. That leaves us with 6k, much lighter, right? Since both sides are even, we can just slice them in half. 3k is congruent to 2. To isolate k, we need the modular inverse of 3. That turns it into a 1 in this modulo 25 system. 51 is our winner. It is just 1 more than 50. And 3 times 17 is 51, so 17 is our inverse. Multiply our 2 by 17, and we get 34. In modulo 25, that is just 9. We are so close. Moment of truth. We take that 9 and plug it back into our original formula. X equals 81k. 81 times 9 is 729. Boom! That is the only number that satisfies both of our conditions. See? When you break large problems into prime powers, the logic becomes so much more manageable. If you want math that actually makes sense, hit subscribe and stay curious.